This is problem number, chapter 6, number 23. And it says, a forester measured 27 of the trees in a large woods that is up for sale. He found a mean diameter of 10.4 inches and a standard deviation of 4.7 inches. So I have an N 10.4, comma 4.7 model that I'm dealing with. We have several questions. First, it says, we're to assume that a normal model applies to this forest, and we can gauge it from this 27 tree sample. Draw the normal model for tree diameters. So I'm going to do that. Make my normal curve. I start with my mean. My mean is 10.4 inches. So I want to make all of my different standard deviation lines here. 3, 1, 2, 3. My standard deviation is 4.7. So let's start with my mean 10.4. Let's add 4.7. So my first standard deviation is at 15.1. Let's add another 4.7. My next one is at 19.8. Let's add another 4.7. No, this is wrong. I'm going to go 19.8 plus 4.7. That's better. So I have 24.5 for way out here, the big trees. Then I have 10.4 minus 4.7. So my first standard deviation lower is 5.7. And I'm going to subtract 4.7 from that. And I'm going to get 1. Now, I'll subtract 4.7 from that, even though it's kind of ridiculous because I can't have a negative tree, right? That'd be negative 3.7. So that's what the normal model would look like for these trees. Part B now says, what size would you expect the central 95% of all trees to be? Well, we know in the normal model, we have this piece right here takes up 68%. And from the second standard deviation negative to the second standard deviation positive encompasses the next 95%. So we would expect 95% of the trees in the forest to have a diameter of between 1 inch and 19.8 inches. The next part of the question reads, about what percent of the trees should be less than an inch in diameter? Well, let's look at the normal model. So we're trying to figure out what percent of the trees, in fact, let me do something here. Let me just use this here so I can clone it a couple times. Clone the page. And let's just clone it one more time so I have plenty of copies. Okay, so I'm going back to this one here. What percentage of the trees should be less than 1 inch in diameter? Well, that means here's our 1 inch in diameter, and we're going this way. And we know that 95% of the trees are between the 2 standard deviations negative and 2 standard deviations positive. That covers 95% of our trees. So that means that this piece here on the outside plus this piece over here on the outside of our 2 standard deviations is equal to 5%. Which means that half of that, which is the negative side on the less than 1%, would be 2.5%. That's the number of trees that we would expect to be less than 1 inch in diameter. And, just so that we know on the other side, the number of trees that we would expect to be more than 19.8 inches in diameter would also be 2.5%. Those 2.5% make up the missing 5% from our central 95%. The next question says, what percentage of the trees should fall between 5.7 inches and 10.4 inches? So we're trying to figure out what percentage is in this section of our normal model. Well, again, we know that between 1 standard deviation negative and 1 standard deviation positive is 68% of the values. Well, half of those are positive on the positive side, and half of those are on the negative side. And we're looking between 1 standard deviation negative and the mean. So I would take my 68%, I would divide it by 2, and I would say that this part in the middle here should be 34%. Just as the trees that should be between 10.4 and 15.1 is also 34%. We take our 68% and we divide it just right down the middle. This last part of the question is a little bit, now just a tiny bit inaccurate. It says, what percent of the trees should be over 15 inches in diameter? Well, it'd be better if it said over 15.1 inches, but they're being a little bit loose. If we know that 68%, so we're looking to fill in this part of the normal curve. What percentage of trees should be greater than 15.1 inches? And we know that this section right here, between -1 standard deviations and +1 standard deviations, takes up 68%, which tells me that the sides here that I was looking at in red over here, plus the lower side over here, is going to be our 100% minus the 68% that's in the middle. So that's 32% between this part of the graph and this part of the graph. But I'm only interested in this part of the graph, which is half of the 32%. So the answer would be approximately 16%. So 16% of trees should be greater than 15.1 inches, or the book says 15 inches.